These are metaballs. They're a fascinating part of computer graphics history. They've been used to create special effects for feature films, and they even inspired a new kind of architecture and industrial design. Stick around till the end, I'll show you an application we made that lets you play around with these. But what are they? The story begins in 1980, when Carl Sagan set out to create his hit science television series, Cosmos. For one of the episodes, Sagan wanted to walk viewers through the process of how DNA works, and he turned to a collaborator he had known from JPL NASA, Jim Blinn. Blinn had been responsible for many of the Voyager spacecraft visualizations, and one of the true pioneers of CGI. For the DNA sequence, Blinn and Sagan wanted to make something that truly felt organic. This was a really difficult problem in 1980. Most of the tools available were based on polygons, triangles with sharp, hard edges. And while there were parametric techniques for creating smooth spheres and cylinders, they wanted to avoid that ball and stick look that was the kind of classic way to visualize molecules. Blinn found inspiration in the world of quantum mechanics. If you have an atom and you have an electron that's orbiting it, you don't really know where that electron is at any given moment. So in quantum mechanics, it's represented as a probability field, a kind of cloud around the atom. What Blinn realized was that he could use a similar technique and represent all of these atoms in these DNA molecules as probability clouds. And where they crossed, their densities would add up. And then by picking a threshold of where that density was above a certain value, he could define a surface. And this surface could be infinitely smooth. By calculating how that surface changed at any given point, he could create lighting and render these. According to Blinn, this was one hell of a project to make, but he persevered and ended up producing some truly groundbreaking animation for the Cosmos series. He wrote up his technique in a paper and he called them algebraic surfaces, or Blobbies. There was one problem though. This technique was very, very slow. It took a long time to render these effects, and if they were going to become practical, optimizations would have to be made. The answer would come from across the ocean in Japan, where a CGI industry was emerging out of Osaka University. Graduate students working under Koichi Omura at Osaka figured out an optimization to Blinn's Blobbies. Instead of an expensive Gaussian calculation, they would use something called a piecewise approximation, basically blending together two cheaper quadratic curves to model the fall-off of the Blobbies and zeroing out anything past a certain distance. It had the additional benefit of being elegant for ray tracing. They called them Metaballs. Meta coming from beyond or to transcend. They got this running on something called the Lynx 1 supercomputer. The Lynx is a rather obscure machine that was pretty fascinating. It was an early parallel supercomputer of sorts, tuned to do things like ray tracing, which was very impractical on other machines. Pioneering artists like Yoichiro Kawaguchi defined the early era of Japanese CGI utilizing this machine. One of the companies that would really harness this system was the Meta Corporation. No, not that Meta. It was Meta Corporation of Japan. They created Metaball modeling and animation software called Meta Editor that ran initially on the Lynx hardware and eventually on Silicon Graphics machines. It was nearly impossible to find screenshots of this software in action, but it produced some of the most sophisticated figurative modeling and animation of the late 80s and early 90s. One selling point was that you could create pretty complex models with relatively lightweight files. As computer graphics was maturing in the late 80s and early 90s, other software creators started to incorporate metaballs in their applications as well. Softimage, which was used to animate the dinosaurs in Jurassic Park, incorporated metaballs as meta clay, which was used in the motion picture Flubber.
You're foldable. You're gullible.
While today these might have a kind of retro feel to them, at the time they were blowing people's minds, and not just in the CGI community, but in fields like architecture and design. Greg Lynn coined the term blob architecture or blobitecture, and started to incorporate these sort of amorphous, blobular shapes into actual buildings. The industrial designer Karim Rashid was similarly inspired, and blobism became a big trend in the late 90s industrial design and product design. In the mid to late 90s, Metaballs remained a solid way to create smooth, organic surfaces. There were various plugins and applications like Bryce 3D allowed users to create these shapes. But on the hardware of the 1990s, they weren't a very interactive tool. And so techniques like Pixar's subdivision surfaces took off as the production standard way of creating things like characters and soft objects in computer graphics. Over the next decade, Metaballs' influence faded, until 2008, when Spore's Creature Creator brought them back to relevance. Their simplicity proved perfect for a tool that needed to be intuitive and simple for a general audience, and the developers were able to use a bunch of optimization tricks to make them interactive. And like I covered in my video on the connection machine, GPUs were beginning to turn smartphones into parallel supercomputers. So I started to get interested in whether we could use that acceleration to make Metaballs more interactive. I began to experiment with rendering Metaballs in compute shaders. Over time, I developed it into a complete application for Apple Vision Pro called Metaballs Spatial. The app is based on Reality Kit, so you could model with physically based materials that actually blend and fuse together, and you can do it in augmented reality. And you can actually export to both USDZ, so you can share these with people or put these creations in your space, or the STL format, and you can actually 3D print your sculptures. But not everybody has a Vision Pro, so recently we released it for iPhone and iPad. So quick plug, if you like this channel, you like these videos, and you want to support it, go try out our app. It's called Metaballs Mobile, and you can get it for $4.99 today on the App Store. So that's the history of Metaballs. Hope you liked today's video. I've been loving the comments, and thanks so much for supporting this channel. It's grown so much recently, and there's a lot more to come. Don't forget to like, subscribe. See you soon.